Here's another grade 11 physics problem for you. A muon, which is a subatomic particle, is moving in a straight line and it enters a detector with a speed of 5.0 times 10 to the power of 6 meters per second, and then it's slowed down at a rate of 1.25 times 10 to the power of 14 meters per second squared in 4 times 10 to the power of negative 8 seconds. How far does it travel while slowing down? So this, at first glance, seems totally scary because what are all these crazy numbers? 10 to the power of 6, 10 to the power of negative 8. Let's just approach it as if those were any other numbers. You have something with an initial velocity, and then it slows down over some period of time. So the acceleration is 1.25 times 10 to the 14 meters per second squared. And we know that that's acceleration because the unit is meters per second squared. Since it's slowing down, the acceleration is going to be negative. Finally, the time period, or delta t, is 4 times 10 to the negative 8 seconds. And we want to know how far did it travel, which is delta x. We're going to look for an equation which has all these different parameters, and that looks like delta x equals vi delta t plus 1/2 a delta t squared. Our goal is to solve for delta x, and here it is already isolated, so it's our lucky day. Now let's just fill in what we know. Vi is 5.0 times 10 to the power of 6. Delta t is 4 times 10 to the power of negative 8. Then 1/2. A is negative 1.25 times 10 to the power of 14. Delta t squared, that's 4 times 10 to the power of negative 8 squared. Whenever we have a bunch of numbers just multiplied together, you can always rearrange the order of multiplication and the answer still stays the same. So this is going to be the same as 5.0 times 4 times 10 to the 6 minus 8. Now, why am I doing 6 minus 8? Remember that an exponent is just repeated multiplication. 10 to the power of 6 is just 10 times 10, 6 times. And 10 to the power of negative 8 is just 10 to the exponent of 8, except on the denominator. Now we can cancel out 6 tens up here and 6 tens down here. And what we're left with is 1 on the top and then 10 to the power of 2 on the bottom, or 10 to the negative 2, which is the same as 10 to the power of 6 minus 8. So that's how we get that there. But let's check out the rest of this equation. 4 times 10 to the power of negative 8 squared, we're going to have to square both of these. So 4 squared is going to be 16. And then 10 to the power of negative 8 squared, well, whenever you have an exponent raised to another exponent, you just multiply it. So negative 8 times 2 is negative 16. So over here, 5.0 times 4 is going to be 20. 10 to the power of 6 minus 8, that's negative 2, plus 1/2. And here we have negative 1.25 times 16 times 10 to the 14 minus 16. Negative 1.25 times 16 is negative 20, and 14 minus 16 is negative 2. 20 times 10 to the power of negative 2, I'll tell you a little trick. 10 to the power of negative 2 just means we move the decimal of 20 over to the left 2 times, which looks like 0.2, plus 1/2 of, and this is the same exact thing, negative 0.2. Half of negative 0.2 is just going to be negative 0.1. So the answer is 0.1 meters, not meters per second squared. I made this mistake. I've just realized while editing, but the question asks for a distance, so the answer should be in meters. That's a silly mistake. I would have lost marks for this, but you don't want to lose marks for something silly after doing all that hard work. So double check your units.